Okay, apparently I had a couple of slides from my lesson 3.3, which was on the second derivative test. I had a couple of slides that disappeared on me. So I'm going to do those separately right here. Finding points of inflection. So let's say that we had a equation f of x equals x to the fourth minus 4x cubed. And we wanted to find inflection points. Now remember, an inflection point occurs when the second derivative is 0. Okay? So pretty simple to do on a problem like this. Take the first derivative, 4x to the third power minus 12x squared. Okay, take the second derivative, f double prime of x is 12x squared minus 24x. All right, set that thing equal to 0. I can factor out a 12x from this thing, and I get an x minus 2 equals 0. Okay, that tells me that x is either 0 or x is 2. So this has two inflection points. It has one at 0 and one at 2. And if I want to find out what those points are, I plug them back into f of x. Okay, so f of 0 is 0. And f of 2 would be 2 to the fourth power would be 16 minus 4 times 2 cubed. So 2 cubed is 8, that'd be minus 32. That'd be negative 16. So I have inflection points are at 0, 0 and at 2, negative 16. Okay. Very simple to do. Okay, remember what happens at an inflection point? That's when it turns concave up and concave down. Okay, so it's switching concavity at the inflection points. So if you think about it, if I have a graph like this, okay, I have an inflection point right here. This part of the graph from here this way is concave down, right? And then from here this way, this is concave up. And there's my inflection point right in the middle. All right, the second derivative test says what does it say? Let f be a function so that f prime of c, f prime of c is 0. And the second derivative exists. On an open interval containing C. Okay, then 1, if f double prime of C is greater than 0, f has a relative minimum at C, f of C. All right, and 2, if f double prime of C is less than 0, f has a relative maximum at C, f of C. Okay. If f double prime of f equals 0, f double prime of C equals 0, then the test fails. Okay, so you don't have a maximum or minimum, but you do have a test fails, but there is an inflection point there. Okay, so do one more example here. Find the relative extrema of f of x is negative 3x to the 5th power plus 5x to the 3rd power. Okay, so first things first, f prime of x. That's going to be negative 15x to the 4th plus 15x squared. Okay, second derivative, f double prime of x, going to be negative 60x to the 3rd plus 30x. So, does this have an inflection point? Yeah, it probably does. Okay, so we'll set this equal to 0. I can factor out a negative 30x here. Whoops. And let's see, I'll have positive 2x squared minus 1 equals 0. So x is 0. And let's see, 2x squared minus 1 equals 0. So 2x squared equals 1. So x squared is 1/2. Ooh. And x is plus or minus the square root of 1/2. So that's going to be plus or minus square root of 2 over 2. So this has 3 inflection points. If I want to find those inflection points, I'm going to go ahead and take those 3 points and plug them back into that equation and figure out what those are. So the easiest one is going to be 0, 0. I'm going to plug them into the original equation. So f of 0 would be 0. F of square root of 2 over 2. Ooh, that's going to be tougher. Negative 3 times square root of 2 over 2 to the 5th plus 5 times square root of 2 over 2 to the 3rd. Wow. Okay. So let's see. Square root of 2 to the 5th power. That's going to be 2 times 2 is 4 square root of 2 in the numerator. And the denominator, 2 to the 5th power, 2, 4, 8, 16, 32. And then over here, plus 5. Square root of 2 to the 3rd power is going to be 2 square root of 2 over 8. That's negative 12 square root of 2 over 32. plus 10 square root of 2 over 8. If I get a common denominator of 30 seconds, I'm going to multiply the top and bottom of this one by 4, so this is 40 square root of 2. So that's 28 square root of 2 over 32, and that'll reduce because 4 will go in there. That'll be 7 square root of 2 over 8. Yikes! All right, so I've got one at 0, 0, and I've got one at square root of 2 over 2, 7 square root of 2 over 8, and you can figure out the negative 1 on your own. Okay, so let's see. If I have these critical points that are at 0, square root of 2 over 2, and negative square root of 2 over 2. Let's put this kind of in order. And I want to test concavity for this thing, the second derivative test. I would pick something like, I've got 5 regions to test. I would pick something like, I don't know, -3, negative 1/2, and positive 3. So I have 4 regions to test. Actually, I could test -1. F of -1. I'm sorry, F double prime of -1. F double prime of -1. This would be 60 minus 30 minus 30. That's concave up. And F double prime is 0. I can't plug in 0 there. The test fails because it comes out to be 0. So that tells me there's an inflection point. And if I test +1, that'll test another region. So that would just be -60 plus 30, which is -30, which tells me it's concave down. Okay. Now, if it's concave up, so if you think about it, if this is concave up, it's going to be a relative minimum. If it's concave down, it's going to be a relative maximum. Yeah, and of course, we don't get anything out of this. Okay, and that should have covered the last couple of slides that we had.